शिर्के सर मोबाईल वगैरे तर हे करा बरं का.
हो हो.
कवडे मॅडम
हा
सायलेंट करून ठेवा आता.
हा सायलेंट केलं. शेनगुप्ता सर. पण मी बघायला ये.
Kode madam.
Hello, I am audible, sir.
Yes, you can start, madam.
Good afternoon, one and all. On behalf of Civil Engineering Department of Dr. Vithalrao Vikhe Patil College of Engineering, I, Dr. Kaude, welcome you all in today's workshop on application of groundwater and watershed management in civil engineering on 24th and 25th May 2020. I am thankful to management, Honorable Deputy Director of Dr. Vithalrao Vikhe Patil Foundation, Professor Sunil Kalapure Sir, Honorable Principal of Dr. Vithalrao Vikhe Patil College of Engineering, Professor U.P. Naik Sir, for providing opportunity to Civil Engineering Department for organizing today's workshop. For the workshop, we have two eminent personalities, Dr. Doke Sir from PREC Loni and Dr. Sevelikar Sir from KK Nasik. I welcome them. Total 280 participants are registered for the workshop. Now, Dr. A.J. Shirke will give brief introduction about eminent personalities. Thank you.
Hello.
Shirke sir, you can start.
Hello. I, Dr. Shirke AJ, coordinator of this workshop. Welcome to all participants and organizing committee of this workshop on application of groundwater and watershed management in civil engineering. Here, I will give the brief introduction of our today's expert and resource person, Professor Dr. S.D. Doke, working as a assistant professor at Department of Civil Engineering, PREC Loni. He has 30 years teaching experience. He is published 50 research paper in national and international journal. He has carried out lineament analysis of Latur district after the Latur earthquake, headed by Dr. B.M. Karmarkar, Government of India. And our second resource person, Dr. Vinayak Sevelikar, working as an associate professor, Department of Civil Engineering, KK College of Engineering, Nasik. And he has additional charge of principal, KK College of Science, Nasik. He has also 30 years teaching experience and he has published 55 research paper in national and international journal. Now, I request to Professor Dr. S.D. Doke sir and hand over to screen to the Doke sir. Doke sir, please.
Okay, thank you, sir. I express my thanks to all organizing committee for giving me opportunity to hold the presentation. I am giving presentation on the topic that is application of groundwater and watershed management. Now it is visible, sir?
Yes, sir. Yes, sir.
Okay. Now, application of groundwater and watershed management. This 2 days workshop, that is on 24th and 25th May 2020, has been organized by Department of Civil Engineering, Dr. Vithalrao Vikhe Patil College of Engineering, Ahmednagar. Now, I have selected the topic groundwater, its estimation, and watershed management. Now, as far as groundwater is concerned, first of all, I will give some important aspects of groundwater. Now, what is groundwater? The water occurring below the surface of earth, occupying joints, cavities, bedding planes, solution cavities, fault zones, fractures, etc. in the rocks is called as groundwater. The main source of groundwater is rainwater. The water which falls on the surface of earth in the form of rain get disposed of in 3 ways. Part of this rainwater evaporates and return back to the atmosphere. Some part it flows in the form of rivers, streams, which is called as runoff. And remaining part of the rainwater, it percolates down, it soaks down by the earth, and it occupies cavities in the rock below the surface of earth. That water is called as groundwater. Now, this groundwater can be classified into three types: meteoric water, connate water, and juvenile water. The large quantity of groundwater which we receive by means of rain and which has been percolated below the surface of earth and which can be used for drinking purpose by giving some minor treatments is called as meteoric water. Thus, meteoric water is large source of water, groundwater, which is available below the surface. Now, the second type of water is called as connate water. The water which has been entrapped in the sediments at the time of formation of sedimentary rock, that is called as connate water. And magmatic water is also called as juvenile water. In magmatic water, as there are various gases which are in dissolved state, this juvenile water cannot be used for drinking purpose. Therefore, main source of groundwater is a meteoric water. Then, as far as water table is concerned, the water table is the top surface of water body which is occurring below the surface. This water table is always fluctuating. In rainy season, it rises up, and in dry season, it goes down. And on the basis of such type of fluctuation of water table, the three different depth zones have been determined. The zone which is occurring immediately below the surface is called as zone of aeration. From this zone, water percolates down to the lower level. In this zone, we don't get water for long period. Water in this zone acts as a water transmitting zone. Whereas below that, there is zone of saturation. This zone of saturation can be further classified into two types: zone of intermittent saturation and zone of permanent saturation. Zone of intermittent saturation is lying between high water table and low water table. High water table means it is water table which we get in the winters, during rainy season. During winters, it is a high water table. And during summers, as water table goes down, we call it as a low water table or summer water table. Now, this zone occurring in between high water table and low water table is called as zone of intermittent saturation. Whereas the zone which is below the low water table is zone of permanent saturation. Hence, it is observed that the shallow wells, dug wells, which have been taken up to zone of intermittent saturation, they yield water only during wet season, during winters. Whereas the deep wells, tube wells, taken up to zone of permanent saturation, these wells are perennial wells. Means they yield water throughout the years. Thus, these are the three main zones, depth zones of water. Then, as far as porosity and permeability of rocks is concerned, now this slide is a slide of sedimentary rocks. That is, it is showing the clastic texture. At our extreme right side, the texture is a clastic texture in which the porosity is there and all the pore spaces, they are interconnected. Therefore, the sedimentary rocks in which there is porosity and pore spaces are interconnected, those sedimentary rocks are permeable. For example, the sandstones, conglomerates, which are having a lot of porosity and where pore spaces are interconnected, they are porous as well as permeable. But sometimes textures are found in such a way that there is porosity, but pore spaces are not interconnected. Now, such sedimentary rocks, though they are porous, they are non-permeable. They are almost impervious. Okay, thus the porosity and permeability depends upon the whether the pores are interconnected or not interconnected, as far as sedimentary rocks are concerned. Now, such type of texture is called as clastic texture. Whereas in igneous rocks, we do not get such type of texture. In igneous rocks, all the minerals, they are interconnected. There is interlocking texture. Hence, we don't get porosity in igneous rocks. Igneous rocks are generally non-porous because of the interlocking textures. During cooling of the lava, these minerals, they undergo intergrowth. And because of intergrowth, very rarely we can observe such type of porosity in igneous rocks. As far as sedimentary rocks are concerned, the porosity reduces because of cementation. Because sedimentary rocks are formed by the deposition of product of weathering of igneous rocks. And when these sediments, they get deposited, in the beginning, they are unconsolidated in form. To convert these unconsolidated sediments in consolidated rock, cementation is required. The groundwater plays very important role in depositing the cementing material around the pore spaces. And by cementation, the unconsolidated sediments get converted into consolidated sedimentary rocks. Therefore, it has been observed that in the older sedimentary rocks, which are of the age older than Gondwana period, they are well cemented. They are almost impervious. Whereas sedimentary rocks which are younger, which are less cemented, there is porosity and the pore spaces are interconnected. Hence, sedimentary rocks, when they are younger, they are porous and permeable, but as they become older and older, because of cementation, their porosity reduces. Exactly in case of igneous rock, exactly opposite case is there. Igneous rocks, when they are fresh, because of interlocking texture, they are impervious. There is no porosity. But as they become older and older, and they are exposed to the weathering, and because of continuous weathering for longer period, the impervious rocks can get converted into porous rocks. Thus, porosity can be developed because of the weathering. Hence, we can say igneous rocks, as they become older, they can be converted into porous rocks. Whereas sedimentary rocks, as they become older, they get converted into impervious rocks. Thus, this is about porosity and permeability of different types of rocks. In our Deccan Trap region, the basalts, particularly compact basalts, they are jointed in nature. And when these joints are interconnected, then only the compact basalts, they are pervious. But if joints are not interconnected, then even though joints are present, these rocks, they are impervious. Hence, the porosity or permeability of igneous rock like basalt, it depends upon nature of joints, joint spacing, nature of joints and joint spacing. If joints are closely spaced and if they are interconnected, then only they are pervious. If joints are broadly spaced and if they are not interconnected, then they are impervious. Now, when the rocks are very much porous and permeable, then we call them as aquifers. Okay. Hence, the sedimentary rocks like sandstone conglomerates, which are having good porosity and pore spaces are interconnected, they are good aquifers. They are good aquifers. Whereas the rocks like igneous rocks, like granites, which are having very good interlocking texture, they are generally non-pervious. Okay, they are impervious. Now, when these aquifers are bounded by impervious layers above and below, then they are called as confined aquifers. As in this slide, this confined aquifer is shown here, which is bounded by aquifer fluid above and bedrock below. the above and below there is impervious formation. Therefore, such aquifers are called as confined aquifer. Whereas this overlying aquifer, it is bounded from lower side by aqueous fluid, but the top surface is exposed to the atmosphere. Therefore, it is called as unconfined aquifer. Both are aquifers, but it is a confined aquifer and this is unconfined aquifer. Now, what is aquiclude? For example, the shale, mudstone, these are the argillaceous rocks. There is some porosity, but pore spaces are so small that even though pore spaces are there, water cannot easily move through these pore spaces because of the very small porosity. And such formations, which though they are having pore spaces, the water cannot transmit through them. They are called as aquicludes. The shales, mudstones, these are the examples of aquicludes. Now, for the storage of groundwater, the most suitable condition is the occurrence of pervious layer enclosed between two impervious layers. And in that also, the most favorable condition is when such formations, the pervious layer bounded above and below by impervious layer, when such formations are subjected to folding, and by folding, a syncline is formed, then what happens? The some portion of this aquifer get exposed to the atmosphere, and through that exposed portion, rainwater, it percolates in that aquifer, and there is no outlet for that aquifer, and hence water remains stored. And such condition is favorable for artesian well also. Now, such conditions are favorable for the storage of water. The aquifers bounded by impervious strata, impervious overlying and underlying strata. Okay. Then about springs. When the water oozes out at the surface from a point, then it is called as spring. Whereas when water oozes out on the surface along a line, then it is called as seepage. There are various conditions for the formation of such type of springs. In desert area where weathering is very tremendous, by weathering of the land surface, many times the lowering of land surface can take place up to the water table. Such type of lowering in deserts is called as deflation. When this deflation takes place up to water table, then at water table, the springs are issued. Such springs are called as depression springs. Therefore, when we say the oases, okay, oases are formed at such places where depression has of the land surface has taken place up to the water table. Now, very common examples in our Deccan Tribe region is the contact spring. When at the contact of pervious strata and impervious strata, water oozes out at the surface, then contact springs are formed. For example, in Konkan region along the Sahyadri ranges, we can observe the laterite is overlying the basalt. And as laterite is porous rock, water percolates through this laterite. And when it comes in contact with impervious layer of underlying basalt, then the springs are coming out at the surface. Okay, such springs are called as contact spring. In sedimentary layers, when the porous sandstone is overlying the impervious shale or mudstone, then contact springs are developed. Okay, the such type of springs are very common in nature. We have seen that we do not get water in the zone of aeration because zone of aeration only acts as water transmitting zone. The rainwater which percolates through this zone, it goes to the lower level and the water table is formed. But sometimes what happens, due to the occurrence of aquicludes or any impervious strata, in the zone of aeration, the rainwater may get accumulated over the aquiclude, and small quantity of water may get stored in this zone of aeration. Such water is called as perched water, and the top surface of this perched water is called as perched water table. As shown in this slide, above the aquiclude, the perched water is occurring. Now, but this water is not in large quantity. We cannot carry out large scale planning on the basis of this water. Okay, this is a perched water. Then regarding artesian wells, as already we have discussed, when the confined aquifer is occurring in between two impervious layers, then water which is percolating through this aquifer, it remains under pressure because as there is no outlet. And when such aquifer is pierced by some means, by drill, then water oozes out along its own head. Such type of well is called as artesian well. When water oozes out on its own head up to the surface, then it is called as artesian well. Such conditions are very common in folded regions. Such artesian wells we do not get in our Deccan Trough region, but in the regions where such type of synclines, sedimentary rocks, folding and faulting is common, in such regions we may get artesian conditions. Then the work of the groundwater, geological work of the groundwater. The groundwater which percolates through joints, cavities, bedding planes, schistosities of rocks, they bring about decomposition, solution, and depollution. Particularly, the groundwater containing carbon dioxide and oxygen in solution, it bring about chemical decomposition of the rocks. Therefore, wherever such type of groundwater it percolates, it bring about decomposition of the rocks through which it is percolating. Then, when there is large quantity of carbon dioxide dissolved in groundwater, it dissolves the soluble material, and mostly the soluble material is generally carbonates, calcium carbonate which is found in the limestone. When such groundwater it percolates through the joints, bedding planes of the limestones, then it dissolves calcium carbonate. And because of solution of calcium carbonate in the limestone regions, the cavities are developed, which are called as we can observe various caves in the limestone regions. These caves are developed due to the solution of calcium carbonate. Large cavities, sinkholes are developed in the limestone regions. Okay. Under appropriate condition, this limestone get deposited in the form of stalactites and stalagmites. When they are occurring in the form of hanging from the roof of the caves, then they are called as stalactites. When they are projecting upward from the floor of the cave, then they are called as stalagmites. Such type of stalactites and stalagmites are very common in the limestone caves. Okay, this is all about the some aspects of groundwater. Now, we'll see one case study. The project work we carried out at in Jalna district at Haveri. Now that is to find out to estimate the groundwater occurring in that area. Because the methodology for measurement of surface water, which is stored in the dams, it is well known. Immediately after rainfall, next day, we can determine this much quantity of water has been stored in the dam. Okay, that easily we can work out because that methodology is available. But as far as groundwater is concerned, there is no proper method to estimate how much quantity of groundwater is available in particular area. Therefore, in this regard, government of Maharashtra constituted one committee that is called as Groundwater Estimation Committee. in 1997, the Groundwater Survey and Development Agency, with the help of this committee, has carried out the estimation of groundwater in some areas. For that purpose, they used some dug wells, which are occurring in that area at different levels. The scattered dug wells they are taken into consideration, and they adopted some methodology. And with the help of that methodology, they have estimated the watershed-wise the groundwater in some regions. Now, by following same methodology, we carried out our project work in Dhavedi village of Jana district. We adopted same methodology, which was adopted by the GSDA and which was given by Groundwater Estimation Committee. Now, what is that methodology? In this methodology, there is a preparation of contour map of 5-meter interval and transfer it to the village map with scale 1:10,000. Then demarcation of surface exposures of rocks. The rocks which are exposed along the nala sections, along the hill sections, they have been demarcated. Then with the help of well inventory forms, we have determined the geological section of each and every dug well. We have selected 14 dug wells from this area. This is the contour map of the Dhavedi village. In this village, we have identified basalt flows occurring in that area. Then, with the help of well inventory forms, we have prepared lithologs. Lithologs are nothing but the sections of dug wells. Now, in this slide, if you can see it clearly, in this slide, there are 14 dug wells. We carried out geological survey of all these 14 dug wells. And these dug wells have been selected in different regions of the same village. Some wells at higher elevation, some wells are at lower elevations. We thoroughly investigated each and every well, and we have prepared lithologs of all these wells. For example, if we consider well number 1, there is amygdalar basalt at the top, compact basalt at the lower level. This is lining. Lining indicates the soft layer, because in the beginning there is a soft material, that is soil. Below that there is AB. Below that there is CB. Like this, all these dug wells, their sections have been prepared. And from all these lithologs, we have prepared one main litholog called as master litholog. This master litholog gives us clear-cut geological section of that area. Now, from RL 581 meter to RL 573 meter, there is a soil. Then from 573 meter up to 567 meter, the red color indicates amygdalar basalt. Then 567 meter RL to 545 meter RL, there is compact basalt. 545 meter RL to 533 meter, 534 meter RL, there is AB, and below that there is a CB. Thus, it is a geological section of that area. Thus, from this we can get the thickness of each flow. Flow number 1 is of amygdalar basalt. Flow number 2 is of compact basalt. Flow number 3 is of AB. Flow number 4 is of CB. Thus, the layers of igneous rocks are called as flows. We use a term flow for the layer of igneous rock. For layer of sedimentary rock, we use term bed. Okay. Thus, these are the 4 flows. First flow is of AB, second flow is of CB, third flow is again of AB, and fourth flow is again of CB. Thus, from this master litholog, we are having thickness and layering of the various basalt flows. Then from these, we have given the colors to this contour map. The 5 this from this RL to this RL, there is the red color means it is the flow of amygdaloidal basalt. This entire area is occupied by AB. Then the blue color indicates CB. This much portion is occupied by AB. Again, this portion is occupied by CB. And at the lowermost level, again, there is AB. Thus, these are the 4 flows of compact basalt, amygdaloidal basalt, compact AB, the red color AB, blue color CB, again AB, again CB. Then, with the help of planimeter, we have determined the area occupied by AB. Okay, with the help of planimeter, area occupied by the flow number 1, AB. That area has been determined. Then area occupied by CB. Again, area occupied by this AB and area occupied by C. Thus, all the areas of these different flows have been determined. Thus, we are having area as well as we are having thickness. Area into thickness gives volume. Thus, we could determine volume of the AB, volume of CB, and which can be used for determining the groundwater potential and estimation. Now, this data is available. The hydrological properties like infiltration rate, specific yield of different types of basalt flows. For example, broadly spaced and columnar jointed compact basalts. They are having infiltration rate 7%. Specific yield is 1.75%. Closely spaced and sheet jointed basalts having infiltration rate 13% and their specific yield is 3%. Hydrothermally altered fresh amygdaloidal basalts 1 to 2% and 0.5%. Thus, these are the various values of infiltration rate and specific yields of different types of rocks occurring in that area. With the help of this, we can determine groundwater potential, that is area occupied by basalt flow into average annual rainfall into rainfall infiltration factor. It gives groundwater potential of that area. Average annual rainfall of that region is 550 mm of the Jalna district. Then groundwater estimation, thus volume that we have determined, volume into specific yield, it gives groundwater estimation. Thus, groundwater can be estimated, its potential can be determined with the help of this work. Then the area occupied by AB in that Dhavedi village is 2.22 square kilometer. Area occupied by CB is 1.96 square kilometer. Their groundwater potential is given here. AB is this much. Compact basalt is 0.11 million cubic meter. Then estimation of groundwater of AB in AB, it is 56.61 into 10 to the power 13 mm cube, and CB is 93.1 into 10 to the power 13 mm cube. Thus, we could determine the groundwater estimation and groundwater potential of the various types of basalts occurring in this area. Then the last topic is the watershed management, management of watershed. Watershed is a total geographic area through which water flows across the land and drains into common body of water, maybe a stream, river, lake, or ocean. That entire geographical area is called as watershed of that particular stream. For example, when we say watershed of suppose Pravara river, means that entire area from which water is brought into that particular river, Pravara, is watershed of Pravara. The Mula River. The watershed of Mula means the entire region through which water it comes into the or drains into the Mula River is called as watershed of Mula. When the Mula and Pravara they meets the main river Godavari, then we can say the watershed of Godavari is entire watershed of Pravara, entire watershed of Mula, and watersheds of all other tributaries of Godavari. That large watershed is the entire watershed of Godavari River. Thus, it is a total geographical area through which water flows across the land and drains into the main river. The watershed boundary follows highest ridge line around stream channels. Quality and quantity of water is affected by activities like mining, agriculture, urban development, etc. Now, there are on the basis of the area which is occupied by the particular watershed, these watersheds can be classified on the basis of size, like macro watershed, which are having area more than 50,000 hectares. The sub watershed, which covers area 10,000 to 50,000 hectares. Milli watershed, it is covering area 1,000 to 10,000 hectares. Micro watershed means it covers area 100 to 1,000 hectares. And mini watershed 1 to 100 hectares. Like this, these are the different types of watersheds. Now, the various objectives of watershed management. What are the objectives of watershed management? By management of watershed, we can control damaging runoff and degradation or conservation of soil and water. We can manage and utilize runoff water for a useful purpose. We can protect and conserve and improve land of watershed for more efficient and sustainable production. We can protect and enhance water resource originating in watershed. We can check soil erosion. So there can be rehabilitation of deteriorating land. The infiltration of rainwater can be increased. We can enhance groundwater recharge. Thus, these are the various objectives of watershed management. Now, there are various structures of watershed management. In that, the most important and which are generally adopted, it is the continuous contour trenches. The trenches taken along the contours, they are called as contour trenches. Along the contours, along the hill slopes, the contours are taken, the trenches are taken along the contours. When these trenches are excavated, the soil which has been excavated is dumped at the margins of the trenches, which are called as contour bunds. And on these bunds, the plantation is done. Then it is called as contour plantation. Such contour trenches, which are 60 centimeter wide, 30 centimeter deep, taken along the contour lines. They are useful in stopping soil erosion, as the water which is running along the hill slopes get accumulated in the trenches and it is absorbed, and thus there is a recharge of the groundwater. Water table increases in that area. Thus, groundwater storage is increased. And it also improves soil conditions. There is the conservation of soil. Thus, there is increase in water table and the conservation of soil. There is decrease in soil erosion. All these things are possible because of contour trenches. Then another civil engineering structure, it is a check dam. A weir constructed across small stream is called as check dam. It cuts velocity and reduces erosive activity. Stored water improves soil moisture and allows percolation to recharge the aquifer. Height of check dam is 1 to 3 meter and length is 3 to 10 meter. Thus, it is useful in reducing erosive power, and also it, because of the storage of water, its percolation takes place and water table increases. Then there are small percolation ponds. Its function is to augment groundwater recharge. Shallow depressions created at lower portions in natural or diverted stream course. It is preferable under gentle sloping stream. It is adaptable where dug wells exist in the zone of influence of 800 to 900 meters. All the dug wells which are occurring in the vicinity of percolation ponds, means which are at a distance of 800 to 900 meters, they can get benefited because of such percolation ponds. And then this major structure, it is well known to all civil engineers, which is percolation tank. The structure is similar to earthen dam. Only thing is that no strict quality control is observed. There are no gated spillways. Okay, but rest of the things are similar to earthen tank. The aim of construction of percolation tank is to allow water to percolate from the reservoir, so that the farmers in downstream region can utilize this water by digging wells. As water percolates in downstream region, in that region the water table rises and it can be utilized by the farmers. Thus, the recharge area downstream should have sufficient number of wells and cultivable land to benefit from the augmented groundwater. The size of percolation tank should be governed by percolation capacity of strata in the tank bed. Normally, percolation tanks are designed for storage capacity of 0.1 to 0.5 MCM. It is necessary to design the tank to provide a ponded water column generally between 3 and 4.5 meter. Okay. Thus, these percolation tanks are very important structures which are useful for improving the groundwater conditions in the surrounding area. Then the gabion structures. The small stones and the boulders, they are put in the mesh, and this is a kind of a check dam, commonly constructed across small streams to conserve a stream flow with practically no submergence beyond stream course. A small bund across the stream is made by putting locally available boulders in a mesh of steel wires and anchored to the stream banks. The height of such structure is around 0.5 meter and is normally used in the streams with width of less than 10 meters. The excess water overflows this structure, storing some water which serve as a source of recharge. The silt content of stream water in the due course is deposited in the interstices of the boulders. With the growth of vegetation, the bund becomes quite impermeable and helps in retaining surface water runoff for a sufficient time after rains to recharge the groundwater body. Then gully plugs. The gully plugs are built using local stones, clay and bushes across small gullies and streams running down the hill slopes, carrying drainage to tiny catchments during rainy season. Gully plugs help in conservation of soil and moisture. The site for gully plugs may be chosen wherever there is a gentle slope, which permits accumulation of adequate water behind the bunds. Thank you. Thank you, sir.
Gupta sir.
Sir. I am.
Yeah, vote of thanks. We are waiting.
झाले का ह्यांचं?
Oh.
Okay. Hello everyone. Here, good afternoon everyone. Today we had a very important session regarding groundwater applications of watershed management. The speaker was a renowned person, Professor S.D. Dokhe sir. On behalf of Dr. Vithalrao Vikhe Patil Foundation and College of Engineering and Department of Civil Engineering, I truly admire the work behind taken upon by the college and our department for arranging such a nice lecture, which will be very, very beneficial for the students as well as the admiring lecturers. On this behalf, I also thank our principal, Dr. Knight sir, our deputy director, Kalapure sir, the HOD of our department, Dr. Kaude madam, the dean academics of our college, Dr. Nauta sir, for giving me this opportunity to share a few thoughts regarding this online session of groundwater recharge and watershed management. I thank all the participants for showing their desperate attempts and registering for this online course. I also thank the valuable notes been given by Dr. S.D. Dokhe sir. And I would like to share that after today's sessions, I'm just posting a feedback form so the participants can just go to the feedback form and give their feedback regarding today's course session. At last and not the least, I would thank those who were directly and indirectly involved in arranging this session. Thanks and thank you all.
Okay, should I end the session?
Yes, sir.